Hello, it's Stat 134, Lecture 32. Last time we talked about the convolution formula for the density of the sum. So let x, y be random variables with s equals x plus y, where x is positive and y is positive. So we have the convolution formula shown here. In particular, we showed if we throw 10 darts and x is the 7th order statistic and y is the 9th order statistic, then y minus x is a beta 2,9. In fact, y, the 9th order minus the 7th order statistic, is the 2nd order statistic, as you can see, since the 2nd order statistic is also beta 2,9. And it makes sense because the spacing between any two of the any two of the darts should be having the same distribution, since it's uniform 0, 1. So there's nothing particularly special about the spacing between the 2nd and 4th dart, or the 7th and the 9th dart, for example. So that's a good thing to know. Today, we're going to go over student comments from the concept test from last time, as well as a triangular density and the convolution formula for the ratio y over x. So last time we did x is standard normal, y is standard normal, independent, probability that x is greater than 2y. You can notice that the image is symmetric in the plane, so the area under the line y is 1/2 x is the same as the area above, which would show that the probability that x is greater than 2y is 1/2. Also, you can note that x minus 2y is having mean 0, and so the probability that that's greater than 0 would be 1/2. And x minus 2y is a normal 0, 5. Standardizing both sides of x minus 2y and 0, we get probability that z is greater than 0, or 1 minus phi of 0. The triangular density is the convolution of the sum of two IID standard normals. And so I asked you guys to find the density when s is between 0 and 1. And this is the easy case, because here we can just use the convolution formula and we get that the density is s. So between 0 and 1 it is s. Again, f of x is 1 for x between 0 and s, because s is between 0 and 1, and s minus x is also between 0 and 1, since x is smaller than s. Next, in the case when s is between 1 and 2, we need a trick. So what we do is we introduce a new random variable t, which is also a sum of two IID standard normals, but the two IID standard normals is 1 minus x and 1 minus y, and that is 2 minus s. And so since s is between 1 and 2, t is between 0 and 1, and by part 1 then we know that the density of t is t, and we can apply the change of variable rule then to find the density of s, which will be 1 over the absolute value of minus 1 times ft of t. Evaluate t at 2 minus s, and you get 2 minus s for the density of s. So that gives us the triangular density as shown in the picture here. Next, convolution formula for the density of the ratio. So when z is y over x, here y and z are positive random variables, then z can be interpreted as the slope. And so the probability that z is in dz is the orange shaded region, and the probability that z is in dz and x is in dx is the green, the darker green region here. And the so the probability that z is in dz and x is in dx can be found as the area, the volume under the joint density above this darker green region here, which is approximately the height of the joint density at x, z minus x, times the area of that dark region, which is dx times delta y, where delta y is x dz as described here. Then we're going to sum all of these volumes as x goes from 0 to infinity. That's an integral, and hence we get the integral from x is 0 to x is infinity f x zx, and then x dz dx, which is the volume of that little shaded green region. And that is the probability that z is in dz. So that tells us that that gives us the convolution formula that the density f of z is the integral of f x zx x dx, and you can split up the joint if x and y are independent. So we did an example of a gamma here, noting that the integral from x to the r minus 1 e to the minus lambda x is gamma of r lambda to the rth. So applying that to this example, if x and y are IID exponential 1, we want to find the density of y over x. We apply our convolution formula, and we recognize that our integrand is a gamma, and we use that identity above to solve the problem, giving us 1 over 1 plus z squared. We then did a concept test that you'll recognize from your homework this week. So here the density, so x and y are IID standard normals. We look at the ratio of y and x, and we see that it's a half. Here z is between 0 and 1, meaning the slope is between 0 and 1 as shown in this picture. The other case is when the slope is greater than 1, in which case now we can only integrate from 0 to 1 over z, because as shown in this picture here, because this this point right here is 1 over z. This x is 1 over z because y here is 1. And we get 1 over 2z squared. Finally, we did this problem. Y is the 7th order statistic and x is the 9th order statistic when we've thrown 10 darts. And we want to find the density for z. So we worked this out, and we show it's a beta here. So we simply use our convolution formula, and we pull out the constant, which is, we pull out all the x's, and so what we get is a constant times z to the 6, 1 minus z, which we recognize as the variable part of a beta 7, 2. And I want you to notice that z here is equal in distribution to just u, the 7th order statistic, when you throw just 8 darts, which you can verify since u7, when you throw 8 darts, is a beta, also a beta 7, 2. Interpreting this is as follows, because we're dividing by, so when we look at y over x, we're essentially making the ninth dart our new 1. That leaves 8 darts to the left of it, of which we want to find the 7th. And we want to find the distribution of the 7th. So what I'm saying is that uniform, the 7th order out of 10 divided by the 9th order statistic of 10 is equal in distribution to the 7th order of 8. So you can check that they're both beta 7, 2, since, for example, the kth order of n is beta kn minus k plus 1. So in this case, the 7th order of 8 is also a beta 7, 2. Just to check you understand, if you throw 10 darts, what's the distribution of u4 of 10 divided by u8 of 10? So it would be u4 of 7, right? Because you're making the 8th dart 1, there's 7 darts before it, and you're looking for the 4th, the distribution of the 4th. More generally, if you throw down n darts and k is less than m, and then the distribution of u, the kth order statistic of n, divided by the mth order statistic of n, will be equal in distribution to the kth order of m minus 1. That's the show for today. Next time, chapter 6. See you then.